Hello, everyone. My name is Henry Canivel, and welcome to the session Cybersecurity Recipes for Mature and Effective Security Content. In today's talk, I'd like to discuss various security use cases and monitoring drivers, Splunk content design tips and tricks to unlock security and operational value out of your data, data inspection, and tactical planning. This is the roadmap for your journey of security data onboarding for today. Some quick information about myself. I am currently a security architect at Splunk for the last several years. My areas of interest within the security and technical domains include data science, automation, Python, and cloud security. I have been using Splunk since 2009 in various roles shared here and would love to share my wealth and knowledge over the years. Feel free to reach out to me on any of these or related topics during the in-presentation chat or anytime via Splunk User Community Slack channel. In our short time today, I'd like to share with you 1. A framework to build your technical requirements to support security use cases. 2. A deep dive plan for the discovery of data visibility. And 3. A couple live walkthroughs of performing due diligence for data engineering. In the security domain, there are a number of specialties, practices, and subdomains that drive data engineering as part of assembling use cases for security data. Here are a few of my favorites, like threat hunting, automation, endpoint telemetry, and threat intelligence. Hopefully, these concepts and processes are not wholly unfamiliar to you. As a technical person, like an engineer or analyst, we are often expected to supply and to support security operational tasks. They may run the business use case, but your task to enable it. Where do you start? What are you trying to do? Oftentimes, you're provided a mission, but not a clear agenda. However, these are common examples that would make up your agenda for your security team, and also for services that drive your business of security operations, and thereby drive your data onboarding charter. Note the similarity and relation to both the list of buzzwords I shared earlier and new ones. In order to begin designing a tactical plan, we need to nail down our primary problem. Oftentimes, you'll be presented with a defined SOC or security use case, but limited definitions for what you need from a particular data source for collection. Or you'll have access to a product or services data, but you need to figure out where it best fits within your security detection portfolio. Sometimes it can be somewhere in between, all of which seems fine. However, what's a real problem for you? You may find yourself in uncharted waters without particular skills, skill sets, or relevant experiences. You may also find yourself gravitating towards one or more of these quotes currently. You may find yourself establishing your limitations or knowledge gaps. From security to operational, Splunk admin to developer, these are very common concerns for those relatively new to either Splunk or security. Don't worry, let's take it one step at a time. One of the hardest parts I feel for technical personnel like engineers is the ability to take a proper scope for a project or task. First of all, narrowing scope for supporting security use cases to the data engineering of source data into Splunk for your use case. 2, emphasize for a clearer definition of data requirements as part of your design phase. What are you looking to do with this data within the Splunk platform? What should be the expected outcome for core use cases? Generate alerts? Dashboards? 3, try to finalize the definition and model for either the SOC use case or the data source as a way of marking boundaries for your forthcoming work. 4, draft and design a data engineering implementation. It's okay to deviate, but you need to set a baseline list of requirements and deliverables for your forthcoming solution. But why this way? For more color and scope, focus on what you can do within Splunk and the data itself. Finalize or clarify deliverables and implementation tasks for execution. both against the source technology and within Splunk itself. I also highly encourage you to leverage defined and tested security use cases as a foundation. Finally, be flexible to discover, capture, and define data engineering requirements through your R&D or staging period before implementing for production. You may discover a critical data use case that doesn't exist before, but be sure to retain that note even if you don't implement it during this go-round. For perspective, here's a preview of the SOC use case lifecycle, where we will focus on the following three phases: design, implementation, and testing integration. In an action-oriented operational model for data engineering, you'll need to ensure your level of effort ties into something specific and tangible for the implementation team to track and execute. Identify those teams like an internal Splunk services team and scope with them what it means to onboard data and who will own the responsibilities for making content against your source data. Let's set the stage for you to switch gears for a second, take a step back, and evaluate our intended goals, takeaways, and expectations out of this talk. What if I told you you can take on the world so long as you set realistic expectations? Whether previously experienced as a security professional, a Splunk specialist, or neither of the two, I want you to be empowered to more actively engage for your Splunk experience and roles in working within the Splunk frameworks. For me, I like to share with you my various roles directly impacting or benefiting Splunk within my career and share with you a real-world workflow or checklist for data onboarding for the benefit of your security personnel. I like to enable you with these new tools and techniques. As an attendee for this conversation, for this presentation, I want you to more effectively draw security value from any data source, possess knowledge to deploy optimized Splunk solutions, and know where to start building custom content and apps for your primary users in mind. These are basic tips and quick areas for you to self-analyze for what you'll need in terms of skill sets and aptitude to drive data engineering tasks to completion. Know who you are, but also challenge yourself to pick up these various areas of awareness or experiences. So, what's involved? Since security is founded upon the nexus of software and IT, this IT management framework for people, process, and technology is alive and well now. For any given security use case, the primary people to consider are stakeholders, like your organization's leadership, audit teams, and IT teams, and your SOC or security team with security analysts and engineers. For processes, there are a number of security-based processes that ultimately will influence your strategies, also your thought processes and approaches for data onboarding. For technology, we'll cover that in a second. People, we will not go into depth reviewing the various stakeholders. For processes, we'll only cover some, but not all of them. Since our focus is for the delivery of data onto Splunk, we will need to take more consideration of the various processes that preceded them for the SOC or the security analyst. We will not review what it means to perform threat modeling in this talk. However, the others can more strongly drive how we approach data onboarding. But first, a quick definition. For data onboarding, in short, it addresses the enablement of operational and security needs by delivering source data into Splunk environments, in our case here. Ultimately, for me, the target audience is our security operations team to maintain their service and environment visibility. From a forensic capability viewpoint, these are the various categories of responsibilities or deliverables SOC analysts aim to deliver. Security teams need the ability to analyze threats and impact to their environments. Here's a larger breakdown of how various common intrusion analysis frameworks distill the forensic work into more consumable piecemeal parts. Note: while the pyramid of pain isn't necessarily a process per se, but a framework to effectively measure or qualify the data engineering or onboarding of various indicators of compromise or attack, or even help your organization recognize the level of effort or return on investment of these IOCs. In effect, the various frameworks is intended to provide context or mapping of a user triggering an event, its context, and the ability to place the event within a timeline to replay potential bad actions. Hopefully, we can natively and quickly determine the severity of the event, either intrinsically within the event capture contents itself, or via extrinsic areas of awareness or experiences. In the end, we need to validate if the data can be captured for post hoc analysis. Here's a SOC use case cycle again for good measure. Most use cases deployed should be framed properly within this framework to flush out any critical details or capabilities to start off. However, you may find yourself with knowledge or visibility gaps. How do we supply the event data for this visibility? Technologies. Here are a few sample vendor landscapes across various domains. For any given software perspective, there are a multitude of vendors hawking their wares and services for IT and other operational teams and organizations. This one is a breakdown of cloud technologies. Many of these logos or companies you should be familiar with. Here's another vendor diagram that seems to cover even more cloud services and vendors for the enterprise. A significantly different perspective to include a category for tech leaders, whether or not they're considered a company that delivers a service within the cloud computing stack. Gets another diagram for SaaS apps and related domains. Notice a call out for IAM and SSO. This vendor landscape focuses on security vendors across various niches or subdomains. Based on various categories of subdomain segmentation, many of them will have strong integration with services across different domains, subdomains, and subsectors. Finally, here's a vendor landscape outside of the typical security or IT domain. This one actually is for marketing across even more subdomains of technologies. So, if this or any other previous diagrams represent your organization, as it may be asking you to deliver data usability in onboarding data, are you feeling a bit anxious, overwhelmed? This does seem like quite a lot of vendors, but my recommendation here for you is to simplify. Focus on what you can enable. This diagram focuses on security-based technologies and aggregating their data into Splunk. Learn to baseline and set foundational expectations. Recognize that there are technologies with an already mapped out integration plan from soup to nuts in terms of data usability out of Splunk. Here are several for the security domain. What's your next step? How do you break these down into more usable chunks? My recommendation is to leverage established frameworks like these listed here. Use them as foundations, at least to minimally help you kick off your discovery of viable data within your original data sources. OWASP offers a logging cheat sheet that I found more cleanly, eloquently, and most comprehensively captures the sheer variety of event types I'm looking for any given dataset, especially for system or system processes, as well as user activities like data exporting or download. Recall the pyramid of pain that emphasizes the recognition for quantifying level of effort for time and resource cost. Likewise here, prepare to set expectations for what is minimally viable versus ideally. Total visibility for any given service or tool will definitely come with costs, and best if you validate or refine requirements to a certain level you and your business use case owner can agree upon. For me, This minimal phase is my default expectation, but I will still evaluate what is possible from the data source itself, at least for due diligence purposes. These are the most common collection methods. Familiarize yourself with these to your comfort level so that you can more effectively evaluate if your technology for your source data offers capabilities or features to leverage these collection methods. Perhaps a deployment methodology unlocks additional opportunities for data collection, such as deploying software into Linux-based VM and leveraging common Linux tools like syslog. For more information on collection methods, here are some resources to get you started. From product documentation to communication platforms like Splunk's user community Slack. Feel free to seek me and many others to help you with your questions. There's a number of channels to check out, like Getting Data In, AppDev, and Where Do I Ask? Now, let's tie these back into Splunk. For collection, I highly recommend the add-on builder for Splunk app or TA packaging to make your life easier, especially if you're less familiar with interacting with internal app resources. Simple API called inputs and Python-based inputs are commonly supported. The Splunk developer documentation provides walkthroughs if you want to build collection externally from Splunk, or how to walk through the same internal Splunk resources. For Splunk content, I highly recommend looking into leveraging macros to map the same index, source type, event type of datasets referenced across multiple searches and dashboard. This helps you scale your detection use cases and management, and also lean more on saved searches and lookups to reuse and repurpose. For dashboards, try to treat them as stubs or post-processing for unfiltered datasets. For data mapping, all roads lead back to Splunk SIM or Common Information Model. Mapping data artifacts like source IPs, usernames, target objects, and actions can be leveraged across the multiple data sources in this manner and can be leveraged to get another level to ES. Doing it early reduces the pain downstream for you or someone else when you need to analyze against this data. The ES Threat Intel framework effectively takes threat intel data and enriches your alert notables, for example. This helps when you need to validate the host name corresponding to a given DHCP IP at any given point. And finally, the add-on builder again. This time, it can really help map your data source fields to SIM really easily and cleanly for you as the app developer. The data onboarding process is pretty straightforward when you need to read it through, but it can be tricky and easy to skip a step. Focus on the data requirements as it should help you define your criteria for done. Here's a comprehensive checklist you can leverage and customize for your security data onboarding. I've included a copy of this in the appendix for easier referencing as well. This has been leveraged from the SOC use case lifecycle, and we won't have time to go through all the various stages, but feel free to work through them outside of this presentation and augment as necessary for your needs. Let's now take a look at a couple case study use cases for data onboarding R&D. For today, we have two technologies. The first one is LastPass, an application product for password management, and the other is a cloud service provider, Google Cloud Platform. With LastPass, as a password management solution, it offers both consumer and enterprise-grade offerings. We use it for managing shared or service account credentials. GCP is a platform for deploying cloud infrastructure to support a company's scalable compute and storage demands. The target data we're looking for with LastPass include the following: login activities, admin service change management, and user activity, sharing credential access, and permission management. With GCP, similarly, we're looking for login activities, admin and service change management, but we're also looking for service and system events. Let's build a recipe for discovering what data is available from LastPass. What do we need? We first look at the target delivery, collecting as much data as possible relevant to the activity and configurations related to link sharing and credential exposure. We also want to validate various methods of collections of the data. We also want to validate capabilities and limitations for what data artifacts can be made available for collection into Splunk. We also want to identify any gotchas that may prevent or hinder progress throughout the implementation process. And finally, develop the implementation plans and milestones as part of that plan. Let's look at the recipe here by breaking it down into what we have versus what we need to do or find out. We have the following ingredients. We have requirements for capturing credential user activity, as well as the requirement for configurations that would indicate potential credential exposure. And we have a requirement to enable user attribution as part of the security use case. For what we need to do, in order to prepare a data onboarding plan, we need to prepare by discovering and validating methods of data collection, scoping for available resources to collect data into Splunk, and we need to identify or make notes of any potential caveats that would enable you to from developing custom scripts or collecting data somehow. And finally, develop the implementation plan itself.
Look, one of the most common first steps I will do for data onboarding discovery is looking at what the product itself has and what you can find on the open web. You see here is different types of links for the enterprise security model, for Reddits, and then other websites. And then here's some documentation from LogMeIn or LastPass itself. This document is called Generate LastPass Enterprise Reports. And so on a document like this, we would go through and identify what offerings does it have or what kind of walkthroughs from support that's documented. In this case, it's referencing the admin console and how it has user activity reports, which is exactly what we're trying to look for here. It captures full URLs in the reports, what's the actual item, the credential, and finally, if it's in a shared folder. So that means something for this product. Some other details you have to enable through the policies it would go through. For the shared folder report, it would kind of show for special folders that are read-only and you share, this is the precise example of what we're looking for this target use case. And then finally, for admin activity, we have the admin activity report. And as we go down to this, there's also integrations with Splunk. So it does have an offering. So right off the bat, it has this integration and it shares it with the user. For admin audit, this is a different type of report or support documentation from LastPass, and it covers the various settings and how you can identify your users that are enforcing or exercising SSO and which ones are enabled. So it's an internal report from the console. So let's take a look at the console itself. So you can see over here, this is a standard user for the LastPass. And if you're an enterprise account and you have the admin role, you'll have this access to this additional console. So in here, advanced options, then you can see there's an API. So let's take a look. So with Enterprise API, here's some different documentation, a sample CID, and how to use the API. So from the reference perspective, we understood that there were user activities and there's admin activities. So, and there was reference to shared folders. So a number of different data sets that we can pull from. User data, shared folder data, and then this is the main one here we're looking for, event reporting. So based on these different parameters you can put inside, you can remove, you can have some samples. Failed login attempts, that's exactly what we're looking for. All right, so let's take a look at, on the internet, examples of that. Enterprise API. Given that there were references for the LastPass reporting API, let's take a look at what we can find as well. So there's still generic reports, or the same report we just found from the support documentation from LastPass, but there's also some GitHub references. some blogs. And so let's take a look at this repo. This person, Jim Aguiar, he created a repo for LastPass reports, and it looks like he's targeting last login, pretty much login activity, and shared folders. So like what we're looking for, what we called out already. So again, requirements for the credentials and the company ID, and then it looks like the output format is generally a CSV file. So just command line based, use Python 3, should be pretty plug and play. So let's take a look at this one. Over here, he uses a sample, very generic Python libraries, which just come standard, so you don't need to add an SDK or a special library to interact with the LastPass API. And so his default credentials over here, it looks like, yeah, looks pretty standard. So you go through the URL, makes a query, and then you just pretty much converts it to a CSV. So pretty standard. So we can definitely leverage something like this if you didn't have any sort of tool to extract that data anyways. So another thing I also like doing is to verify what integrations with Splunk, and we already saw it in that support document. So let's see some other direct references. So I created one a long time ago with a LastPass report collection. So we can also take a look at this one. So what I have published. Right. So this example with LastPass I created several months ago. And so some basic requirements in terms of, like I mentioned earlier about the API key with this prov hash, the CID, and I pretty much get 3 different areas. One is event reporting, the second one about user inventory, collecting the different types of users, and also profiles and details, and then shared folder information, what folders within the enterprise subscription are your users creating shared folders and enabling it. And so you can track that type of use case, the administration in URLs. The next thing I want to share with you is from this TA that I built, is that it has been certified through App Inspect for Splunk Cloud and the standard Splunk Enterprise. For the versions, I upgraded to version 8, and also we can see here it also supports for SIM version, the latest SIM versions. So let's take a look at the TA itself. I downloaded it already onto my file system. And so one of the biggest things you have to track for LastPass data or any other enterprise data is that the data can be mapped to the Common Information Model, CIM. And so that typically the way you track that for TAs, you have to look in 2 particular files. The first one is tags and event types. For data models, they primarily look for what tags are included as part of your data sets. And so over here for users, groups, folders, and events, I pretty much tagged it for either assets and inventory here, and also for users, so identify users, and also for web activities for within the shared folder. So when you're accessing, you can, it's most common for you to track access activity through web access, so it's easier if I wanted to make sure it's captured there. And also for events, for reporting events, I have authentication and change activities tracked. For event types, within the data sets, so it's just pretty standard, just making sure that the search can map against these different source types. Can be whatever format. So some other things to look at when you're reviewing TAs would be props and transforms. Is there any parsing of any fields? What's included? I have a number of different source IPs and actions and objects as well. And from a transformation, you can see it as it extracts the various artifacts from the fields. So that concludes our review of the LastPass TA that I wrote as it can be used for enterprise security. There are other artifacts within the Splunk TA or app you would want to consider when building your own, for example, dashboards or searches or macros. So I leave it to you to kind of create your own as well. I personally, when it comes to TAs, I like focusing the TA to extract data and also to collect data. For any UI, I like pushing that off to a Splunk app or customizing it itself. So for me, this is what I want to make sure that it's light and configurable for the various distribution use cases that you as a Splunk admin can have. So let's wrap up our data discovery for LastPass data. With target delivery, activity, and configs to track sharing activities and credential exposure, we're able to identify that the vendor has an event reporting API endpoint, as well as other endpoints that are related. We're able to determine user attribution through the configuration of user references and as exposed within the audit logs. You need to configure special policies in order to expose that for them. For validating methods of collection, the vendor supports two different methods. The first one we saw within documentation, directly referencing Splunk Cloud hack delivery, pretty much sending to the Splunk version of a webhook. The other option is through an enterprise API, where the reference of the event reporting API, shared folders, and also user management. For scopes, we want to look at available resources for collecting into Splunk. When we do it ourselves, we can look at GitHub, and we can look at Splunk base for what resources are there, what tools have other people have already made. Finally, any gotchas. We look at requiring enterprise subscriptions. In this case, you need an enterprise subscription and an administrative role to review and configure these settings. You also need to configure and customize the audit logs to enhance information. In our case over here, it would be shared folder objects, as well as users and different types of policies. And finally, we talk about developing implementation plans. You want to work with the service owner to configure access, data quality of audit logging. You want to leverage APIs and potentially validate the TAs, and we did a walkthrough of that. Next, let's build a recipe for GCP. Our target delivery, our use case for GCP is to collect as much data possible for IaaS access and service administration. In building the recipe, let's look at what we have. For ingredients, we focus on requirements for access events to the platform. We also look at service administration events, onboarding new services, toggling, enabling, disabling, and finally provisioning events like creating new objects, new instances, new snapshots, new storage. When you look at what we need to do, let's prepare. We look at the validating the various methods of collection that GCP offers or other parties with GCP. We validate the scope for available resources and also identify gotchas. And then we progress to cooking, we develop our implementation plan for GCP. Let's take a look at what we can find for GCP audit logs. Right off the bat, we find a dedicated documentation for audit logs out of GCP. Captures 4 different major types: admin activity, data access, system events, and policy denied. The first 3 are pretty straightforward, what you're looking for and what it provides. Let's look at policy denied. For policy denied audit logs, it focuses on denying access to users or service accounts based on the security policy violations that you set forth on the platform. And for many cloud access brokers, this is exactly what you're looking for, what you want to customize based on various policies from legal or from your IT teams in terms of managing what is accessible and what should be enabled. When you enable these types of policies, it's easier to track when rogue access has been either enabled or attempted. For exporting these logs, Google Cloud has some limitations, both in size, we can see here for the 4 different types, but also for how far back, retention. How far back can go by default? It's 400 days for admin and system events, and for 30 days for policy denying data access. Other things to consider over here would be pricing when we're talking about these different types of data. When you look at the left side over here for this panel for within the operation suites, we see that there are different types of security logging that Google Cloud offers. This is absolutely great. From access transparency, you have the cloud audit, what we've seen over here, but also for Google Workspace. Google Workspace is the new name for G Suite. So that means email, calendar, drive, and those types of services. Then more information on the audit log types, how you collect it, and other ways of different types of audit data like BigQuery. So you can either pull it from the app engines, from the service, or from BigQuery and IAM as well. So this is absolutely great. Let's also look at Splunk and GCP, how the two can be connected. We have two different documents over here, one by Google regarding the scenarios for exporting the data, but also from Splunk regarding the partnership, our strategic alliance, the Splunk strategic alliance. For exporting, GCP notes that there are two different main methods of getting the data out of Google Cloud. The first one is using the Splunk HTTP event collector, or HEC. You leverage a pub-sub model for that data flow. And also the pull-based method seems pretty straightforward from the standard APIs and use the add-on. From the pub-sub model, it basically over here covers that you have to build some infrastructure from your Google Cloud environment to enable pushing to effectively the object storage, and then consume it from or push to a HEC container, from that container to the HEC endpoint. And there's more details over here. On the other side, we have from Splunk a Google add-on, the Splunk add-on for Google Cloud. You see that it's been already approved for Enterprise as well as for Splunk Cloud for version 7 and through 8. Also enables for SIM. Let's take a look at how the Splunk TA bridges the Google data to Splunk over the data models and SIM as we want to onboard the data for enterprise security. For the TA, we look at three main areas once again for tags, event types, and props and transforms. For tags, we can see that there are three unique event types: the GCP PubSub Audit Log, G Suite PubSub Audit Log, and finally the GCP VPC Network Flow. That's a mouthful. So for each of these, we can see that different types of tags that apply to different data models. For GCP PubSub, we're seeing authentication and cloud data models. For G Suite, or now Google Workspace, we're seeing authentication and cloud as well. And then for NetFlow, we see communicate, network, and cloud. So all three of them are identified for the new cloud data model. And so the areas that we would probably focus on is authentication for the audit. When you look at the props and transforms, we can see a number of different fields that are being extracted. We see different logs that are being collected, monitoring from the PubSub, billing, metadata, but not all of them are going to be relayed and integrated for the various data models. We see from messages over here, we see references where it's collecting authentication data over here and user information, extracting from the various fields. For looks like we're parsing for SIM over here, SIM authentication data model, and so on and so forth. We see more examples of specifics for extracting authentication data, and there's references for VPC flow logs and the lookup tables as well to leverage as part of the TA. Let's wrap up our data discovery for GCP Data Collection. For target delivery, we focused on collecting as much data possible from this GCP platform, focusing on access and service administration. We found that GCP offered a number of different audit logs available for collection, from data access to denied policy, as well as admin activities. The other types of data we found was Google Workspace audit logs and other special use cases like BigQuery as well. For methods of collection, we found that the recommended solution by both Google and Splunk is the PubSub model. This is for scale and also for a variety of different data sources that you can centralize the data output from the Google Cloud platform into Splunk. They support two different methods. From a push methodology, you can use the Splunk HEC, or in other words, a webhook, or we can pull it into Splunk directly using a Splunk TA as it leverages the API to integrate with the PubSub. Scope for available resources, we looked at both Splunk and Google as we have jointly published content and solutions. For GCP, they offers a PubSub in terms of infrastructure, and then Splunk, we offer a TA to collect from the PubSub if you want to use that method as opposed to HEC. For any gotchas, you need to be aware of the PubSub model is dynamic as it can scale both for the variety of data sources and also for the volume of it, but also it requires budget and operational cost. From a development implementation plan, again, we recommend working with the service owner to configure access quality and data quality of audit logging, to leverage your API, and to validate the TAs. All right, let's summarize what we learned today. Given security use cases and desired data quality, we focused on how to target your product technology, what data they are able to offer, what documentation you're able to find, and also the various methods of collecting it into something like Splunk. We look at reviewing different resources from the vendor itself for their products, but as well as third parties, what they can develop and publish through GitHub or through other means for collecting into Splunk as well. So my overall recommendation for you as the Splunk admin, developer, or standard user to pretty much identify as you onboard to work with your service owners for flushing out these gotchas for subscriptions, for permissions, to making sure that you streamline that process and you build your checklist. You establish your checklist to measure your success for the data onboarding. Thanks, everyone. If you have any questions, you can definitely find me on the Splunk user community Slack as @Henry. My email is hcbomb@yahoo.com, and you can definitely find me in the B-Sides 21 channel. Thank you and have a great day.